Hello everyone, welcome back to the channel. So for the first time today, I've decided to allow you people to see the handsome face behind these videos. Well, some of you have been asking me around campus whether it's really my voice behind these recordings. So yes, it is my voice behind these recordings. So now you can finally put the face to the voice. Well, today we're starting a very important chapter in engineering drawing, which is isometric, right? Now, isometric drawings are a form of pictorial drawings that allows you to represent a 3D drawing onto two-dimensional surfaces while keeping, accurate proportions, right? Well, these drawings are particularly advantageous in a field where precision and clarity are essential, right? As they allow for the accurate representation of an object in a way that is easy to understand. So in this learner unit 4, we will learn how to construct isometric drawings from first and third angle. Right. So now there is one rule and one rule only that you cannot break in isometric drawing. Well, once you break that rule, it means your drawing will be distorted and you will particularly fail the question, right? Now, in an isometric projection, the object is rotated or positioned in such a way that the angles between any two of these three principal planes or axes, which is X, Y, and Z, are equal at 120 degrees, as seen in the figure below, right? Now, this is what they call the 120 degrees rule. Now, this orientation allows each axis to be represented in its true scale without any distortion. Now, the equal angles create a balanced visual representation where the proportions of the object are preserved, right? Okay, so I want us to entertain this problem that I already have here on my A3. We have to convert this orthographic drawing into an isometric drawing, right? So we have the first and the third angle there. These two drawings, they look like they're the same, but they're not really the same. Well, they're kind of like the same, but then the orientation of the drawing is going to differ between the two drawings. Right, now I gave you a statement in class, two statements by the way, that every time you see drawings side by side, one is a front view, one is a side view. Every time you see views, one on top of the other, one is a front view, one is a top view, right? Now, whether which one is which will depend on whether it's first or third angle, right? Now, let's focus on this one and draw this one first, right? Now, when you look at this one, you can easily tell that this is the front view, right? And that should be the left view. When you look at this one, this third angle, this one can still be the front view, and then this one is the right view. Not that it can, it actually is the front view, and this one is the right view. Now, let me show you the difference between the two. Now, when you look at this drawing, if you look at it from this way, right? Because the left view is actually observed from the left, isn't it? It's observed from the left of the drawing. Now, if you look at it this way, you are going to see this line right there. You will see that line, and you will see that line on top, isn't it? They are both, the three of them are visible lines, right? Now, when you look at this one, now, since this is the third angle, well, this one is the front and that one is the left, right? Since this is the third angle, the right will be on the right, the left will be on the left, right? Now, this is the front view and that is the right view. Now, if you observe this drawing from this side, right? The right side, right? If you observe it from this side, you won't be able to see this line now, will you? That's why it's dotted lines, right? You won't be able to see that line. That's why it's dotted line, because you're observing the drawing from the right side. So that's why it's dotted line, and this one makes it the right view. Now, when you observe this one from the left side, you can see that line, you can see this line, you can see that line, then this one is the left view, right? Now, let me show you the difference between the two drawings, right? Now, I said, when you are given an orthographic drawing like this, you have to imagine this as differentiation and integration, right? In mathematics. Now, let's say from orthographic, you are differentiating to isometric. Now, when you want to integrate, you have to integrate back to the orthographic, right? Now, when you differentiate these two isometric, if you integrate it and then it gives you that, that means something is wrong somewhere, right? Now, if you differentiate that, you have to integrate it back to that, right? You should be able to integrate that back to that. So if you differentiate this, you should be able to go back to that. If you differentiate that, you should be able to go back to that one. I'll show you the difference as we go on. Now let's start by entertaining this one. So you need your 30-degree set squares, 30-degree set square in order to be able to successfully draw this type of drawings, right? Now this, you should leave it here, and this should give you the 30 degrees, 30 degrees, and the vertical line, 90 degrees for now, right? We'll discuss about the isometric and the non-isometric lines as we carry on with the questions. Right, just gonna start my drawing right there. Now, where you start your drawing matters, right? You need to be very careful about that, because if you start it in the wrong place, you'll find that your drawing, it goes over the border lines, right? So it matters where you start. Should be careful. Seems like I'm gonna have a problem there, so I should just shift this right there. That's fine. So we said, okay, let's say this is our X, our Z, and our Y. So we said an isometric line is a line that is parallel to this line, and that line, right? Any line that is not parallel to those lines, it is a non-isometric line, right? Now, when you look at orthographic, each and every line that is either vertical or horizontal like this, 90 degrees or 0 degrees or 180 degrees, it is going to be an isometric line, because these lines are going to be parallel to one of these three, right? So if you have an orthographic drawing and it has lines like this and like that, vertical lines and horizontal lines like this, those lines are going to be isometric lines, and they are all going to be parallel to either this one, or that one. Always, né? Always. That will always be the case, right? So now let's look at this drawing. So since this is the front view and that is the left view, the left view should appear on the left side, né? The front view then can appear on the right. If this was the right view and this the front view, the right view was still gonna be on the right side, and then the front view on the left side. Now here you have what? Front and right. The right view should be on the right side. The front view will be on the left, right? I hope we agree on that one. So if you have the left there, it should appear on the left when you draw an isometric drawing. If you have the right should appear on the right when you draw an isometric drawing. Always, not sometimes, always, right? Now let's start. I'm going to tell you something else. So if this is going to appear on the right, or on the left, sorry about that. If the left is going to appear on the left, can we then agree that this point D, this point D is going to appear right there on the origin, right? In this corner. That will be our starting point, right? Now I'm going to show you something else. Let me just measure. Okay. So from D to E, let's say we start on this side, we're going to start by producing the front view, then we're going to produce the left view, because that's the most convenient way to start this drawing. So from D to E, which is also the same line as this one, from D to E, it is said to be 20 millimeters, right? Just going to measure 20 millimeters there. 20 millimeters should be there. Now, here's what I wanted to say. That is point E, right? Now, every time you have a point, that point should have 3 lines coming to it. Ne? The line from X, the line from Z, and the line from Y. Ne? Let me show you how that works. So from D, point D, we have the line from X, Y, and Z, right? It should have 3 lines coming to it or leaving it, right? And then point E, it has the line from Z, right? So it lacks the line from X, right? And the line from Y, like this. Now you have 3 lines, one line, and one line that way, right? All these points, they're supposed to have a line, like 3 lines coming to it or leaving it, right? Now, these lines are going to be light lines. They're what we call projection lines, right? So you don't have to erase them. Projection lines or construction lines, you can call them either. So we have point E and point D right there, right? Now, let's go and find point F. Point F is from E to F, right? Which is said to be, if this is 25, then it's 60 minus 25, which will give you 35, right? Now you're going to put 35 there. 1, 2, 3, 35 is right there, right? Now this point is going to be, okay, this point is going to be F right there, right? Now point F has one line which is along X, right? Now it needs a line along Z, a line along Z, a line along Z, and it also needs a line along Y. Just lift this. It also needs a line along Y, like that, right? Now it has 3 lines coming to it. And then we're going to point A, right? Point A, it is said to be 30 millimeters, right? From point F, 30 millimeters from point F. Can measure there. 1, 2, 3, 30 millimeters is right there. And this is point A, right? Point A has one line to it, right? Then you need the second, which is along X, like this. And then you also need the third, which is along Y, like that, right? There's 1, 2, and 3, right? And then from point A, we're gonna produce B, right? And then B is 25 millimeters away from A. We're gonna put it right there. We're gonna put it right there. And that should be B, right? And then point B has one line along X, right? Now it needs a line along Z, like that. And it also needs a line along Y, like this. And remember, one more thing, before I forget, this thing is only 30 degrees when it's on top of that. It's only 30. Once you lift it and you hold it like this, it's no longer 30. It's just a ruler, right? So you should make sure that it's always on top and this is secured so that your lines will be parallel, because we deal with parallel lines here. So B has 1, 2, then 3. It's complete, right? Then B, a line from B and a line from D, a line from B and a line from D produces C, right? A line from B and a line from D produces C there. Now, point C has one line along Z, a line from along X. Now, because the line from C going that way is going to be dotted lines, you do not draw that, because in our isometric drawings, we do not want hidden details. So the line from C going that way is going to be a hidden detail. You do not entertain it, right? Then, now you can make this dark. So now you know this is going to be visible lines there. Just make this dark. Just like that, right? This is your front view, right? Now, a point from D, this is the front view. Now we are dealing with the left, right? A point from D is I, right? Along this line is I. So we're going to put I there. I is 35 millimeters. 1, 2, 3, 35 is there. There it is. That's I. Like this. Now, I has one line. It has one line along Y. So it needs a line along Z. Like that. And then it also needs a line along X. But that line is going to be dotted lines because it's on the other side. So you don't draw it. You leave it like that, right? Now, a line from I, and a line from E, a line from I, a line from E produces H, isn't it? A line from I and a line from E produces H. There, right? Now, H has one line along Z. It has one line along Y, coming to it or leaving it. Then it needs the third line, which is along X, like that, right? Then H is complete, just like that. Now, let's take it from the top. From A line from A to J, right? It's also 35, isn't it? It's also 35. Then you can measure 35 like this. Let me just erase this one because this was just for construction's sake. It's not really part of the drawing. I can leave it short like that. No? Doesn't need to be long. And then a line from A, I'm just gonna measure there, is 35 to J. Ne? 1, 2, 3, 35 should be somewhere there. And that should be J. So J has a line along Y, right? So it needs a line, it needs a line along X like this. And then it also needs a line along Z like that. Did I measure that correctly? It misses there. It misses there. It missed this side. I did not measure well, ne? But it really doesn't matter. It's just for practice sake. And let me just, sorry about that. It means I did not measure well. So if I did measure well, this is what's supposed to happen, like this. The point J is supposed to be there. Sorry about that. The point J is supposed to be here, né? If I measured correctly. But don't let that distract you from what's important. And this goes that way, like this, né? So a line from a J has Y, X, and Z, right? Just like that. Then you can darken it. You can darken it. So like that. I think I have everything. Yeah? Yes. So now this is that. Now, since you differentiated from here to there, when you integrate this, it should bring you to that one, right? Let's try to integrate it. Now, this is our left view. Remember, this is the reality of the object. The left view is on the left, the front view, the right view is on the right. So here, the left view is this one, which leaves this to be the front view. So if this is the left, according to the arrangement of first angle, it has left there, right there, and top there, right? Now, if this is the left, it's going to be that, isn't it? Which leaves this to be the front, and it's going to be that, isn't it? So we get rid of that. So it brings us back to that one, isn't it? So when you differentiate, you should be able to integrate it back, right? Now, let's say you were to take this and put it there, right? Let's say you were to take this and put it there. This would be the front view. According to the arrangement that we have, the arrangement for top view, the top will be there, the front will be there, the right will be there, and the left will be there, isn't it? Now, let's try to integrate this back to that. Let's say it was differentiated from that. Now, let's try to integrate this back to that. If this is the left view, that should be the right, isn't it? Now, when you check here, that doesn't look like the right, does it? It's the front. And the left is not that as well. So this one cannot come to that, but it can go to that. So now let's see the difference when you try to make to draw this in isometric drawing or isometric view, if you like. Now let's bring this a bit down there. So now we're gonna put our three principal axes there. We're gonna have just start there. I hope it's not gonna get to that other drawing. Planning is essential, hey? Now, this is Z, that is X, that is Y. Now you see the right. The right is supposed to appear on the right side, on your right hand. And the front is supposed to appear on your left hand here, according to this drawing. Now, when you check there, this says, what is it? 60 millimeters there, and you see, if you check this one, the point D on the first one was there, but then now, because the right view, the left view is going to be this, the right view is going to be that, this is going to be viewed from the right, this is going to be viewed from the left, isn't it? So now, this is point C, right? This and this are identical, by the way, This is point C. You see, point C is going to be there, isn't it? Point C is going to be there, right? Now, if point C is here, that means this view will be going that way, right? Now, let's measure. It's 60 millimeters from there, which you can easily measure. Let me use that. 1, 2, 3, 4, 5, 6, right there. And this is from C to D, isn't it? That is D. C has 3 lines coming to it. You can leave that alone. D has a line from Y, then it needs a line from Z, like that. Does it need a line along X? No, it doesn't, because that line is going to be hidden details. Now, from the bottom to top, which is C to B, right, is 50. This side is 50 because it's 20 plus 30, right? Now you're gonna measure 50. There. 1, 2, 3, 4, 5. Right there. Now that's number B, right? Then B has 1 line to it. You need the second. And you need the third. Like this, right? Just like that. Right. And then let's start by producing this side first. From A to B, isn't it? A to B is 25. 25 should be there, which gives you A, right? A has 1 line to it. It needs the second, and it also needs the third. Curves to this way, right? And then A is supposed to produce F there, and F is 30 millimeters down. 1, 2, 3, like this. That's F. F has one line to it. It needs the second. Does it need the third? No, because the third is going to be hidden details there. So leave it out. And then point E, which is point E there, is there, right? It has one line, second line. Does it need the third? It definitely does need the third there. Something like that, right? Now from E to H, isn't it? From E to H is 35, right? From E to H is 35. So we can measure 35. 1, 2, 3, 35 will be there. So it means I should remove this A, this table. A, 1, 2, 3, 35 should be there. And this should be H. Let me reduce this as well so that the drawing will be visible. So this is point H. It has one line, right? It needs the second, like this, which is just gonna end there at this line. And it also needs the third, which goes down. But is it gonna be necessary? No, it's not gonna be necessary, right? Okay. Now from A to J, isn't it? So we have to measure, which is what? 35. 35 from A to J. 1, 2, 3, 35 is there, right here, right? This is J. Then J has one line. It needs the second. There's the second, right? Then one line, second. Does it need the third? No, the third is not going to be necessary. Now it produces another point there, which is behind on the other side. So, which is actually the one in front here. But because I didn't put the alphabets there, let's just forget about it. So that point that it produced, it needs 1, 2. Does it need the third? Of course it does. Like this, right? And then this point right there, it has 1, 2. Does it need the third? No, it doesn't, right? Then your drawing is actually complete. Let's make it dark. There it is. So you see the difference between the two. This one is facing that way. This one is facing this way, right? So now if they want this one, give them that one. If they want this one, give them this one, to avoid you regretting at the end of the day. Thank you very much.